In the vast, dark expanse of our solar system, far beyond the familiar orbits of planets like Mars and Jupiter, lies a realm of ice and shadow. This is the Kuiper Belt, a donut-shaped ring of icy bodies left over from the formation of our solar system billions of years ago. Here, at an average distance of nearly 6 billion kilometers from our Sun, orbits the most famous resident of this distant neighborhood, Pluto. For decades, this tiny world was little more than a faint point of light in our most powerful telescopes, a mystery on the very edge of everything we knew. It was a place that captured our imagination precisely because it was so far away and so unknown. Scientists have long been fascinated by Pluto for a very important reason. We believe that objects in the Kuiper Belt are like time capsules. Because they are so far from the Sun and have remained largely undisturbed, they are thought to preserve the original materials from which our entire solar system was built. By studying Pluto, we are not just looking at a distant, icy body. We are looking back in time. It offers us a chance to understand the building blocks of planets, including our own Earth. What was the early solar system like? What ingredients came together to form the worlds we see today? Pluto holds clues to answering these fundamental questions about our own origins. Before we could begin to answer these questions, we needed to get a much closer look. From Earth, even with the best telescopes available for many years, Pluto appeared as a blurry, indistinct dot. We could learn some things, like its approximate size and the length of its 248-year orbit around the Sun. But its surface, its geology, and its atmosphere remained hidden from view. This lack of knowledge created a powerful drive to send a robotic explorer on the long journey across the solar system. The challenge was immense, requiring a spacecraft that could travel faster and farther than almost any before it, all to achieve a brief, fleeting glimpse of this enigmatic world. The allure of Pluto, therefore, has always been a combination of its remoteness and its scientific promise. It represents the frontier of exploration within our own solar system. It is a world that challenges our definitions of what a planet is and reveals the incredible diversity of objects that share our cosmic home. Its story is one of discovery, of technological achievement, and of the human desire to push the boundaries of our knowledge. As we prepared to send a mission to this distant outpost, we knew that whatever we found would change our understanding of the solar system forever, revealing secrets that had been kept in the cold and dark for billions of years. To unlock the secrets of Pluto, NASA embarked on one of the most ambitious missions of exploration ever conceived. The mission was called New Horizons. In January 2006, a spacecraft roughly the size of a grand piano was launched from Cape Canaveral, Florida, on a powerful Atlas V rocket. It was the fastest spacecraft ever launched from Earth, a necessity for its incredibly long journey. Its destination was so far away that the journey would take nearly a decade. The New Horizons probe was designed to be a robotic geologist, chemist, and photographer, packed with sophisticated instruments to study Pluto in detail as it flew past. The journey itself was a marvel of celestial mechanics and precision engineering. To gain the incredible speed needed to reach Pluto in a reasonable amount of time, New Horizons performed a gravity assist maneuver around the giant planet Jupiter in 2007. As it swung by Jupiter, the planet's immense gravity acted like a slingshot, flinging the spacecraft onward at an even greater velocity. This flyby was not just for speed, it was also a dress rehearsal. The team tested the spacecraft's instruments on Jupiter and its moons, ensuring everything was working perfectly for the main event at Pluto years later. For the next 8 years, New Horizons silently sped through the void of space. On July 14, 2015, after a journey of nearly 5 billion kilometers, New Horizons finally arrived. It did not stop or orbit Pluto. It was traveling far too fast for that. Instead, it performed a high-speed flyby, racing past Pluto and its system of 5 moons at over 50,000 kilometers per hour. During this brief but intense encounter, which lasted only a few hours, all 7 of its scientific instruments worked tirelessly, gathering as much data as possible. They snapped thousands of high-resolution pictures, measured the composition of the surface, and studied Pluto's thin atmosphere, collecting more information in those few hours than we had gathered in the 85 years since Pluto's discovery. The data collected by New Horizons was so vast that it took more than a year to transmit it all back to Earth. The signals, travelling at the speed of light, took over 4 hours to make the one-way trip from the spacecraft to the antennas of NASA's Deep Space Network. As the first images began to arrive, they stunned the world. The blurry dot we had known for so long resolved into a complex and dynamic world, full of geological wonders that no one had expected. The New Horizons mission was a spectacular success, and it completely rewrote the textbook on Pluto and the outer solar system. Among the many breathtaking images sent back by New Horizons, one feature immediately captured the public's imagination and scientific curiosity: a massive, bright, heart-shaped region on Pluto's surface. This iconic feature, which stretches over 1,600 kilometers across, became the defining symbol of the new Pluto. Scientists named the western lobe of this heart Sputnik Planitia, in honor of Earth's first artificial satellite. This was no ordinary feature. It was a vast, deep basin filled with frozen nitrogen, methane, and carbon monoxide ices. It is, in effect, the largest known glacier in our entire solar system. What makes Sputnik Planitia so extraordinary is that it is geologically alive. The surface of this vast ice plain is divided into large, polygon-shaped cells, typically 20 to 30 kilometers across. Scientists believe these patterns are the result of slow convection, similar to the way wax churns in a lava lamp. Warmer, slightly less dense nitrogen ice from deep within the glacier slowly rises, spreads out, and then cools and sinks back down along the edges of the cells. This process means the surface of Sputnik Planitia is constantly renewing itself. It is estimated to be no more than 10 million years old, which is incredibly young in geological terms, meaning Pluto is not a dead, frozen world, but a place of active geology. This discovery completely challenged our ideas about how small, cold worlds could behave. We had long assumed that a body as small as Pluto and as far from the Sun would have lost all its internal heat long ago. Without an internal heat source, geological activity should have ceased billions of years ago. Yet the evidence from Sputnik Planitia told a different story. The heat required to drive this slow convection might be coming from the decay of radioactive elements within Pluto's rocky core, or perhaps from some other, as yet unknown process. The existence of this giant churning glacier suggests that even in the coldest reaches of the solar system, there can be surprising and ongoing activity. Furthermore, the immense weight of the ice in the Sputnik Planitia basin has had a profound effect on Pluto as a whole. It is thought that the basin likely formed from a massive impact early in Pluto's history. Over time, the basin filled with dense nitrogen ice. The sheer mass of this ice caused Pluto to reorient itself, a process called true polar wander, so that the heavy basin settled into a position directly opposite Pluto's large moon, Charon. This massive, frozen heart has literally shaped the entire world, influencing its orientation, its geology, and its ongoing evolution. While the great heart of Sputnik Planitia dominated the first images, New Horizons revealed other equally stunning landscapes. On the edge of the nitrogen glacier, the spacecraft discovered towering mountain ranges. Some of these peaks rival the Rocky Mountains in North America, soaring up to 3.5 kilometers high. What makes these mountains so remarkable is what they are made of. On Earth, mountains are made of rock. On Pluto, where the surface temperature is a frigid -230 degrees Celsius, water ice is as hard as rock. These majestic mountains are, in fact, enormous blocks of water ice that form the bedrock of Pluto's crust. The presence of these massive ice mountains provides another clue to Pluto's active nature. They are not smooth and eroded like ancient mountains would be. Instead, they appear jagged and relatively young. This suggests that geological forces have pushed these mountains upwards in the not-too-distant past. The nitrogen ice of Sputnik Planitia flows around the base of these water ice mountains, creating a stunning landscape of glaciers winding through towering peaks. The interaction between the softer, more volatile nitrogen ice and the hard structural water ice creates a dynamic and varied terrain unlike anything seen elsewhere in the solar system. Perhaps one of the most surprising discoveries of all was that Pluto has an atmosphere and it has a blue haze. When New Horizons looked back at Pluto after its closest approach, it captured a breathtaking image of the sun backlighting the dwarf planet. This view revealed that Pluto is enveloped in multiple layers of a thin, bluish haze, extending more than 160 kilometers above the surface. This was completely unexpected. The blue color is likely caused by sunlight breaking down methane gas in the upper atmosphere. This process creates complex hydrocarbon molecules called tholins, which then slowly settle down onto Pluto's surface, giving some areas their reddish-brown color. This thin atmosphere, composed mostly of nitrogen with traces of methane and carbon monoxide, is also incredibly dynamic. It is believed to be supported by the ice on Pluto's surface, particularly the vast expanse of Sputnik Planitia. As Pluto moves along its long elliptical orbit, its distance from the Sun changes dramatically. When it is closer to the Sun, some of the surface ice turns directly into gas, thickening the atmosphere. When it moves farther away, the atmosphere freezes and falls back onto the surface like snow. The New Horizons flyby happened at a time when Pluto was moving away from the Sun, so we caught the atmosphere in the process of this grand seasonal cycle. The New Horizons mission painted a picture of Pluto not as a simple uniform ball of ice, but as a world of incredible diversity and complexity. Across its surface, we found a stunning variety of terrains sitting side by side. There were ancient, heavily cratered highlands covered in a dark, reddish material, which suggests these areas have remained unchanged for billions of years. Right next to them, we saw the youthful, smooth plains of Sputnik Planitia, which are constantly being resurfaced. This juxtaposition of old and new terrains shows that Pluto has had a long and varied geological history, with different regions evolving in different ways over time. In addition to mountains and glaciers, the spacecraft spotted strange, bladed terrain in an area informally named Tartarus Dorsa. This landscape consists of massive ridges of methane ice, some standing hundreds of meters tall, forming a pattern that looks, well, almost like giant snake scales or blades of grass. Scientists believe this unique terrain may have been formed by a cycle where methane ice transforms into gas and then refreezes onto the surface in specific patterns over millions of years. We have not seen anything quite like this anywhere else, which really highlights how unique planetary processes can be under the extreme cold and low gravity of the outer solar system. New Horizons also gave us our first close-up look at Pluto's family of 5 moons. The largest, Charon, is so big, about half the diameter of Pluto, that the two are often considered a binary system, a double dwarf planet. Charon also turned out to be a fascinating world in its own right. It has a massive canyon system stretching over 1,600 kilometers across its surface, far longer and deeper than Earth's Grand Canyon. It also has a distinct reddish North Pole, a feature nicknamed Mordor Macula, which is thought to be caused by gases escaping from Pluto's atmosphere and then freezing and chemically altering on Charon's cold surface. Pluto's 4 smaller moons, Styx, Nix, Kerberos and Hydra, were also revealed to be surprisingly odd. Instead of being spherical, they are elongated and potato-shaped. They also do not rotate neatly like our moon does. Instead, they tumble chaotically as they orbit the Pluto-Charon system. This strange behavior is likely due to the complex and shifting gravitational field created by the two larger bodies they orbit. The discovery of these tumbling moons adds another layer of complexity to this already fascinating miniature solar system, showing just how different planetary systems can be from our own. While the New Horizons mission gave us our first and only close-up view of Pluto, our exploration of this distant world is far from over. A new and incredibly powerful tool has joined the search, the James Webb Space Telescope, or JWST. Launched in 2021, the JWST is the successor to the Hubble Space Telescope, but, it's much larger and is designed to see the universe primarily in infrared light. This is a crucial capability for studying cold, distant objects like Pluto, because they emit most of their faint heat in the infrared part of the spectrum. The JWST can analyze the light coming from Pluto with, honestly, unprecedented detail. Its advanced instruments allow scientists to perform detailed spectroscopy, which means breaking down the light from Pluto into its constituent colors. By doing this, they can identify the specific chemical fingerprints of different materials on its surface. This helps us create much more detailed maps of the distribution of ices like nitrogen, methane, and carbon monoxide, as well as the reddish tholins. We can actually see how these materials are arranged across different geological features and how they might change over time with Pluto's seasons. It's a bit like being able to perform a chemical analysis of Pluto's surface from billions of kilometers away. One of the key goals for the JWST, as of our current understanding in late 2025, is to monitor Pluto over the long term. New Horizons gave us a brilliant snapshot in time, but Pluto is a dynamic world. Its thin atmosphere is expected to change significantly as it continues to move away from the Sun on its long orbit. The JWST can periodically check in on Pluto, monitoring changes in its atmospheric pressure and composition. It can also watch for any changes on the surface, such as shifts in the patterns of frost or activity in Sputnik Planitia, giving us, a movie of Pluto's evolution rather than just a single photograph. Furthermore, the JWST is not just studying Pluto. It's also a powerful tool for exploring Pluto's neighborhood, the Kuiper Belt. It can study other trans-Neptunian objects, or TNOs, with the same incredible detail, analyzing their surface compositions and looking for signs of activity. By comparing these other icy worlds to Pluto, scientists can build a more complete picture of the conditions in the early solar system. The JWST's power allows us to study many of these distant bodies for the first time, providing critical context for understanding just how special, or how typical, Pluto really is. Pluto's story is not just one of scientific discovery, but also one of scientific debate and reclassification. For 76 years, from its discovery in 1930 by Clyde Tombaugh at the Lowell Observatory, Pluto was known to schoolchildren and scientists alike as the ninth planet in our solar system. It was the smallest, the most distant, and the most mysterious member of the planetary family. However, as our technology improved, astronomers began to discover other objects in the Kuiper Belt that were similar in size to Pluto. The turning point came in 2005 with the discovery of an object named Eris, which was initially thought to be even larger than Pluto. This discovery created a problem for astronomers. If Pluto was a planet, then Eris should be a planet too. And what about the other large objects that were being found? Should they also be called planets? It seemed that our solar system might have dozens of planets. Or perhaps the definition of planet itself needed to be reconsidered. This led to a heated debate within the scientific community. In 2006, the International Astronomical Union, or IAU, the organization responsible for naming celestial bodies, met to settle the issue and formally define what it means to be a planet. The IAU established 3 criteria that a celestial body must meet to be classified as a planet. First, it must orbit the Sun. Pluto does this. Second, it must have sufficient mass to assume a nearly round shape due to its own gravity. Pluto also meets this criterion. However, it was the third rule that caused the controversy. A planet must have cleared the neighborhood around its orbit. This means it must be the dominant gravitational influence in its orbital path, having either swept up or flung away other smaller objects. Pluto, being just one of many objects in the crowded Kuiper belt, does not meet this third condition. As a result, the IAU reclassified Pluto as a dwarf planet. This new category was created for objects like Pluto, Eris, and Ceres that around and orbit the Sun but have not cleared their orbital neighborhood. The decision was, and remains, controversial. Many scientists and members of the public felt that Pluto's historical and cultural status as a planet should have been preserved. Alan Stern, the principal investigator of the New Horizons mission, has been a vocal opponent of the reclassification, arguing that the clearing the neighborhood rule is poorly defined. Regardless of the label, however, the discoveries from New Horizons have shown that Pluto is a world as complex and interesting as any of the official planets. The story of Pluto is intricately linked to the exploration of the vast region it calls home, the Kuiper belt. This distant realm is not empty space. It's actually teeming with countless icy bodies, remnants from the dawn of our solar system. The discovery of Pluto in 1930 was just the first hint of this massive population of objects. Today, we know of thousands of Kuiper belt objects, or KBOs, and we believe there are hundreds of thousands more waiting to be found. Exploring this region helps us understand the full scale and inventory of our solar system and provides context for Pluto's own story. The New Horizons spacecraft, after its historic flyby of Pluto, continued its journey deeper into the Kuiper belt. On New Year's Day 2019, it performed another flyby, this time of a much smaller KBO named Arakoth. This object, located more than 1 billion kilometers beyond Pluto, was the most distant object ever explored up close. Arakoth turned out to be a remarkable contact binary, composed of 2 separate flattened bodies that had gently merged together. Its pristine, unbattered surface suggests it formed very gently, providing powerful evidence for how the building blocks of planets, known as planetesimals, may have come together in the early solar system. The search for new worlds in this distant region continues from Earth-based observatories and space telescopes. In May 2024, astronomers announced the discovery of a new candidate for a dwarf planet, temporarily named 2017 of 201. This object is estimated to be about 700 kilometers wide and follows an extremely long and elongated orbit, taking roughly 25,000 Earth years to circle the Sun. Discoveries like this are rewriting the map of our outer solar system, showing that it is a much more populated and dynamic place than we once imagined. Each new discovery adds another piece to the puzzle of how our solar system formed and evolved. Interestingly, the study of these distant orbits is also being used to search for something much larger, a hypothetical giant planet, often called Planet 9 or Planet X. Some astronomers have noticed that the orbits of several very distant KBOs seem to be clustered together in an unusual way. They believe the gravitational pull of a massive unseen planet, perhaps 10 times the mass of Earth, orbiting far beyond Neptune, could be shepherding these objects into their strange orbits. While the existence of Planet 9 remains a theory, the discovery of objects like 2017 of 201, whose orbit does not fit the pattern, adds new complexity to this exciting search. From a faint, blurry dot to a vibrant, complex world with a frozen heart and towering ice mountains, our understanding of Pluto has been completely transformed. The New Horizons mission revealed that this small, distant body is not a simple, inert ball of ice, but a place of surprising geological activity, with churning glaciers, a layered atmosphere, and a landscape of stunning variety. Pluto has challenged our assumptions about where we can find active worlds, and has shown us that even the coldest, darkest corners of our solar system can hold incredible wonders. It has become a symbol of the beauty and complexity that awaits us at the frontiers of exploration. The legacy of Pluto extends far beyond its own icy surface. Its reclassification from a planet to a dwarf planet sparked a global conversation about how we define the objects in our cosmos, and forced us to recognize that our solar system is more diverse than the simple model of 9 planets we grew up with. Pluto stands as the king of the Kuiper Belt, a third zone of the solar system that is fundamentally different from the inner rocky planets and the outer gas giants. It is a gateway to this vast realm of icy worlds, each one a relic from the solar system's birth. As we continue to study Pluto from afar with tools like the James Webb Space Telescope, and as we discover more of its neighbours in the Kuiper Belt, we are piecing together a more complete history of our own cosmic origins. These distant worlds are not just curiosities, they are scientific treasures that hold the chemical and physical clues to how planets, including our own, came to be. They are the leftovers from the great construction project of our solar system, preserved in a deep freeze for 4.5 billion years. By studying them, we are learning more about ourselves. Pluto's story is a powerful reminder of why we explore. It is a testament to human ingenuity, the ability to send a robotic emissary on a decade-long journey across billions of kilometers to glimpse a world we have never seen. And it is a lesson in humility, showing us that the universe is always more surprising and more wonderful than we can imagine. Pluto is no longer just the last stop on a tour of the planets. It is the first outpost of a vast, unexplored frontier. Its enduring mystery continues to immortalize, promising that there are still great discoveries to be made in the darkness beyond.